All right, Algebra 1B students. Welcome to part 4 of our video on lesson 12.6. We're going to finish up our section on combinations and permutations in this video. Now in our last video we were looking at the permutation kind of notation and formula, and remember it involved the exclamation points, right? It involved the number of things you have, factorial with the exclamation point, factorial as we call it, over the difference between how many things you have and how many you want, factorial. That was when we were looking at permutations, which obviously had an order to them. We talked about how many orders you could put 9 batters in. We talked about how many ways you could order 8 swimmers for a race. And in this video, we're going to talk instead about something called a combination. A combination is a selection of objects without regard to order, meaning the order doesn't matter. So you're just taking like 100 things on a menu and you're going to choose 2 of them. It doesn't matter what order you pick them in, it just matters which ones you pick, right? So that's kind of their example here. If you're selecting 2 side dishes from a list of 5 at a restaurant, the order in which you choose the side dishes doesn't matter. So that's a combination, not a permutation, because the order does not matter, okay? Now, the formula and the notation that I want you to notice here in this key concept box is very similar to what we dealt with permutations. The permutations notation was N, the number of things you have, and then a big capital P, and then R was kind of how many things we wanted to put in order, right? So we have 25 kids out for the baseball team. How many ways can we order 9 of them to be our starting lineup, right? So that's 25 and 9. And it's the same thing when we do combinations. It's still how many things do we have, and R is how many things do we want, how many things do we want to choose from, right? How many things do we have, how many things do we want? And C is for combination. How many combinations can we make? The formula is also quite similar, but we've added one extra piece. The permutation formula, if you remember, was just n factorial over n minus r factorial, meaning we take the difference, we subtract them, n minus r factorial, right? N factorial over n minus r factorial. That was the permutation formula in itself right there. That was it. But in this, when we're talking about combinations, we add something else to the bottom of the fraction because there are less ways for us to do combinations than there are for us to do permutations, right? So what we do is we put down here the r factorial as well. So that's obviously the number of things that we want to choose factorial. As an example, let's look here at C8C2. That's 8 choose 2. You got 8 things, and you want to choose 2 of them. Okay, so 8 factorial we know goes on the top of the fraction. 8 factorial because that's how many things we have. We have 8 things, 8 factorial. And just as a reminder, that is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom of the fraction, again, we do 8 take away 2, and that makes 6 factorial, so we put that on the bottom as well. 6 times 5 times 4 times 2 times 2 times 1. But we also put on the bottom 2 factorial by itself. So not 8 minus 2, but just 2 factorial by itself as well on the bottom of the fraction. So then you see, okay, here we have this nice little formula, 8 factorial over 2 factorial times 6 factorial, and that should make some sense, right? It's the number of things we have on the top of the fraction. The number of things we have is the top, and then on the bottom it's the number of things we want times the number of things we have minus the number of things we want, right? So it's number of things we have on the top, and then it's number of things we want on the bottom times the difference between the 2 factorial as well. Now once we have these set up and we understand what the factorial part means, now we can look at our big long fraction and cancel some things out, right? So again, we cancel out the 6 and the 6, the 5 and the 5, the 4 and the 4, the 3 and the 3, the 2 and the 2, the 1 and the 1, and all we're left with is 8 times 7 on the top, but then we just have that r factorial on the bottom. And that r factorial is always going to be there. because we're going to use that n minus r factorial to cancel some things out. Or, if we want to, depending on which one's bigger, we'll just cancel out as much as we can. But you'll always have something left on the bottom, so you will have to do a division in order to get your final answer. You will have to divide to get your final answer. Okay. Now, let's look at another example in maybe a more real-world situation here. There are 20 people that report for a jury duty. When you're an adult, you have to put your name. The government has your name filed, and sometimes you get called for jury duty in a certain place where you have legal residence. 20 people show up, and then the attorneys want to choose people for the jury. Right? So 20 people show up, but they only choose 12 for the jury. And this question is about how many different 12-person juries can be chosen. 20 people show up. How many different 12-person juries can be chosen? Well, that sounds like a 20 and then a big capital C, 20C12, right? 20C12. Now, 20C12, if I were to write it all out, 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right, that is the top of my fraction. That is 20 factorial, top of my fraction. Now the bottom of my fraction, of course, is 12 factorial, which is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's multiplied by 20 minus 12 factorial, and 20 take away 12 is 8 factorial, so this is 8, 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. And now I'm going to have to do some serious math here to figure out what this all equals. Right? Now, the first thing I'm going to do is cancel out all of these numbers, the 8, the 7, 6, 5, 4, 3, 2, and 1. Those are all gone. But I also want you to realize that the 12, 11, 10, and 9 also get canceled out. 12, 11, 10, 9 are over here as well. 12, 11, 10, 9. So those can go away. This is what I'm left with. 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13, all divided by 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So if I do that all on my calculator, the top of my fraction ends up being 507 this gigantic number, 5079110,400. That's the top of my fraction. And the bottom of my fraction ends up just really being 8 factorial. And 8 factorial is this number, 40,320. 40,320. So if I divide those two, 507,911,0400 divided by 40,320, what I end up with is 5,911,0400 divided by 40,000. What I end up with is 125,970. 125,970 different 12-person juries that can be chosen. Okay, so I understand in this case there is a lot of math involved, a lot of multiplication, but we'll use a calculator to help us get these very, very big numbers, 125,970 different possible juries. Okay, I have one here for you to try as well. This one is how many different ways can 3 types of flowers be chosen for a bouquet if a flower store has 15 different types. 15 choose 3 is what I'm asking you to do here, 15C3. So we'll set up our combination formula with our factorials, then solve. Once you have that, pause the video, figure that out. Then when you're done, come on back and I'll show you what we should have. The correct answer here is 455 different selections. Now that obviously comes from, we know, 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 being divided by 3 times 2 times 1 multiplied by 15 minus 3 is 12, so 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we know that all of these go away. Gone, 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 gone. All of this is gone, gone, gone. And all I have left is 15 times 14 times 13 divided by 3 times 2 times 1. When we multiply those together and those and divide, we get 455. If you have questions about combinations, how they're different from permutations or how the formula works, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.